Welcome to the Matter Matters instructional video. My name is Lori Kudlak.
I'm Liz Meredith. Key thing that you guys are going to need to know before you get ready for your e-lab is what is matter.
What is matter? Matter is anything that takes up space and has mass.
Matter, like what? Give me an example.
A brick. A brick has mass. A brick takes up space.
Okay, what about water?
Water definitely is matter. It does occupy space and it has a mass.
Okay, so we talked about a brick, we talked about water. What about air? I can't feel anything. I can't really see anything. Does it matter?
Does it matter? Of course it matters, and it is matter.
Air is a type of gas, and gases are made up of what we call atoms. And those atoms are actually a part of matter. So I guess you could say everything on Earth matters.
Everything does.
I know, right? What's a property? Property like my watch? Property like my earrings? Hey, that's mine! Give it back! Matter actually has what we call properties. Now that word property doesn't mean the same thing as if you say your land is your property or your house is your property. Property, actually, what's another word for property?
Characteristics.
Characteristics. So if I say that matter has mass, right, that's a property?
That's a property.
Okay. What if I said it has density?
Did you call me dense?
Well, you know, I'm just saying.
Hey!
So what if I said then it also maybe has volume?
That's a property as well.
All right, so those are all what we call properties or characteristics of matter.
There are also 4 states of matter. Do you know what those 4 states are?
Ohio and California.
Not those states. There are different states of matter. A solid, which would be...
like the brick we talked about.
Okay. A liquid.
Like the water that we talked about.
Exactly. How about this one? Gas.
The air that we talked about, because as we said, air is matter.
Okay, but there's one more that you might not be thinking about. It's called plasma.
You mean like in my TVs? There's 2 different types of plasma. There's one that's naturally occurring, and we actually find that in a lot of stars that are up in space. The other one, though, could be man-made, and this is kind of like what you see in your plasma TV or even in fluorescent light bulbs.
How about that?
I know.
So remember that brick that you had?
Yeah.
It was a what?
Solid.
Okay. A solid has a definite volume and a definite shape. But if we were to take something like gas or even liquid, do they have a definite volume?
Well, I know that if I start with 80 ounces of water, no matter what container I put it in, it's always going to be 80 ounces of water.
Okay. Does it have a definite shape?
No, because if I accidentally spill water, it goes everywhere.
So it changes.
What about gas?
Does gas stay put or does it move around?
I guess it moves around.
So the only thing that's left then is plasma. Does plasma have a definite shape?
I don't think so.
Does it have a definite volume?
I don't think so. But you know what? It's got so much energy that those particles are flying off of one another. They actually break apart into separate particles. So your electrons and your protons are actually broken apart because there's so much energy in that plasma. So I bet you couldn't keep it in a definite shape or definite volume.
That's pretty cool.
Pretty cool.
Those are the 4 states of matter.
But I have a question. What makes them different states? Like, why is a brick and liquid water is liquid?
Let's think about that one.
The temperature is what makes a material the material that it is. So it makes me wonder, though, what is it exactly about the heat that makes it change from a gas into a liquid or to a solid. And it's actually that heat is a type of energy. And solid particles actually tend to just vibrate a little bit. They're usually pretty cold and they're pretty tucked close together. If you add heat or energy to it, it's going to cause those particles to what?
Move around a lot more.
Exactly, which means they're going to push off of each other, they're going to spread out, and that's how we get liquids and gases. If I have something that's really cold, what do you think it's probably going to be?
Probably ice.
Probably ice. Well, as I add heat, it is kind of warm in here, then that solid's probably going to become what?
It's going to melt.
Oh.
And it may become a liquid. Might become a liquid.
It could become a gas.
It could go straight to a gas. You know what that's called?
Ah. We have these things called phase changes. So if I go from a solid to a liquid, what would I call it?
Melting.
Melting. Okay, kind of like ice melts, right? When I leave it out.
Right.
Well, what do I call it when it goes from a liquid to a gas?
Evaporation.
Evaporation. So what if we did opposite of evaporation, where the gas turns into a liquid? What would that be?
That would be condensation. Do you ever notice if you have a glass of water with ice cubes in it, it's warm outside, what happens to the outside of the glass?
It gets little water molecules around it.
That's
Water
condensation.
Oh. Condensation also happens in clouds, where the water vapor is up in the air, it condenses down, and guess what happens if the cloud gets too full?
Rain!
And then, what's the other one? If I take a liquid and I turn it into a solid, because it gets colder, what do we call that?
That would be freezing.
Freezing. I bet our audience is pretty familiar with those words.
I bet they
Melting,
are.
freezing, boiling. But I wonder, is it possible for a material to go from a solid, skip the liquid, and go immediately into a gas?
It is.
And what's that called?
That's called sublimation.
Oh, kind of like what comets do.
Exactly.
Oh.
Maybe a more common example would be something like dry ice. Have you ever seen that?
Ooh,
That's
yes,
pretty cool.
that stuff's pretty
Looks
cool.
like fog that comes over top. It's pretty
Is it possible then for a gas to go directly back into a solid, not becoming a liquid in the middle stage?
So you mean the opposite of sublimation?
Yeah.
That would be deposition.
Oh, kind of like frost that forms on the ground. How it's cold, the air molecules in the air are gas, but when it's on the ground and it's cold enough, it becomes frost.
Looks like frost.
Ah. It's pretty cool about matter and everything, but can matter actually go through changes?
Matter can go through several changes. One would be a chemical change.
A chemical change occurs when one or more substances are changed into new substances with different properties.
We can also go through a physical change.
A physical change occurs when one or more physical properties of a substance are changed.
So give me an example of a physical change.
Crumpling up a piece of paper? Because watch. It's a piece of paper. It's still a piece of paper.
You're absolutely right. Now how about chemical change?
If I take a log and I burn it.
Exactly. It can't go back to its original log. It goes through a process to become something different called
Ash and smoke and heat through the fire.
exactly.
Those are actually signs of a chemical change. Color change, the heat that's given off is actually a sign of a chemical change. Even other things like if it gases or if it bubbles, those are all signs that a chemical change is actually taking place. Wow, after all that, I think my brain matters a lot. Get it? Matter? Matter?
Everything. Matter matters.
Yeah, matter matters. Which matter matters. I bet they're ready to do the E-Lab coming up pretty soon now, huh?
And I bet you they're smart enough to know all the answers by now. Now that you know the basics of matter, you become the experts. So now you get to help the lab director in your Matter Matters E-Lab.
Because remember, you matter. This is Lab Director Meredith.
And Lab Director Kudlak.
We are signing off for the day. Wishing you well on your Matter Matters E-Lab.
Over and out.
Bye, guys.